Hi everyone, Greg here. So today I'm going to show you how to take control of the terminal and make interesting interactive applications. Most of what I'm going to show you, you could do with N-cursors, and so you might wonder why not simply do it with that library. Well, there's a couple of reasons. I generally prefer a minimalistic design. I prefer to do things myself as much as I possibly can. To create a terminal application where you don't use any libraries except for the standard C runtime libraries allows you to have the entire application in a single binary file. And that makes things more convenient rather than having to go through an installation process. It used to be the case back in the olden days that programs would just work that way. You would just copy the binary file and you were ready to go. It's a modern trend where more and more you have to go through an ever more complicated installation process. And personally, I don't view this as progress. So that's the first thing. Also, N-cursors might not be installed on the system you're going to use it on. Also, if you want to use N-cursors, you're going to have to spend time to learn it. And you might as well use that time learning to do it yourself. Okay, making the library yourself means that it's going to be more streamlined to your needs. It's going to be easier to use. You're going to remember more quickly how to use it afterwards when you've not been using it for a long time. And also, that's a more personal thing, but I find it more satisfying when I've done more of the work myself and I've been more in control of what the machine is actually doing. So let's get into it. So I'm going to start, as is the tradition, with a simple Hello World program. So I'm going to use a text-based editor this time, since I'm in the terminal anyway. Right, and so nothing special here. Okay, so one thing I may want to add here is some color. Okay, let's start with the cool stuff first. So we could add some color. So, well, the colors are actually managed by the kernel, so it's just a matter of giving the kernel the right byte sequence in order to make it clear which color you want to use. So what I'm going to do here is I'm going to create a new header file. I'm going to call it TC for terminal control. And I'm going to input the following byte sequences in there. Okay, so now I've put those escape sequences there. So we have the normal color, the red color, green, yellow, etc. Every color comes in two shades. You have the normal shade, and then B stands for bold, so the bold version of that. So now let's try this the way you use this. I'm gonna save that. I'm gonna go back to the main.c. I'm gonna include this header file. And then here I'm simply gonna put in %s and then %s. And let's have it in yellow. So yellow, and then I'm gonna go back to the normal color. So I save, I recompile. And now if I run the program, I have it in yellow. Now at the end of my printf, you saw me go back to the normal color, and you always want to make sure you go back to the normal settings. If you don't do that, once your program is done executing, those settings will just persist and everything will be in yellow. Now the reason you're not seeing this here is because I have this prompt in color, and so Bash is actually outputting those byte sequences for me in order to create the blue and green colors. And so this is how you'd get away with it in this instance, but you can't rely on that. So it's a good practice to always go back to the normal settings before you exit your program. Okay, what else do we want to do? What about clearing the screen? So this is also just a matter of an escape sequence. So I'm going to go back to this header file, and I can very easily implement this with a macro. So what you're seeing here is the escape sequence to do a clear screen. So now let's test this. I save that, go back to my main, and I do tc clear screen, recompile, and now it clears the screen. Another thing you may want is controlling the cursor, right? Make sure the cursor goes where you want it to, and so that you can print text anywhere on the screen. Okay, so I created this macro, move cursor X and Y, and then here you see the X and the Y value being incorporated into this escape sequence. Let's go back to here and we do tc move cursor, and let's say 10 and 5 just for argument's sake. And is this gonna work? Let's see. Okay, so now I did add a couple of extra escape sequences for the backgrounds, a background red, etc. If we look at what that looks like in the main.c, right, this time I'm doing the hello world. I'm adding an extra escape sequence to get a green background, and then if we compile that, then we see the hello world with this green background. If I want to make the entire screen with a background, then I can simply do, if I get, let's say, a green background, or maybe a red background, so and there we are. Okay, so I'm gonna change that back because it doesn't look great. Okay, so now that's all I want to say about colors. Let me explain a small bit about different input output streams. So if I have a look at the printf here, when a C program runs, there are automatically 3 files open, right? So in Unix/Linux, everything is a file. So you have those 3 file descriptors. 0 is standard input, 1 is standard output, and then 2 is standard error. So for to print out the errors, that's a separate output stream, and that's file 2. So I could write literally this, and that would be equivalent. Or I could also write this. Oops, no, this, okay? And all of those things are equivalent. So let me just recompile here again, and you see the exact same thing happens. Now, what if I create a different terminal? So I have another terminal here. What I'm now going to do here is I'm going to type tty, and I'm seeing here the path to a file. Okay, and you see it has the name 1. So what I'm going to do here is I'm going to open, and now what that will allow me to do is from this terminal I'll be able to print stuff onto this one. So let's see how that works. And there you go, right? So now, okay, you might wonder why is that useful, and by the way, if I do this in an actual terminal as opposed to like this kind of simulated GUI terminal, but in an actual terminal, so if I do Alt Control F1 and try the same command in a terminal, then I'm gonna get something more like this. And then if I use that as a file name in my program, then I'm actually able to output to those terminals. Now, with the way that OBS is recording, this is more difficult to demonstrate, but you can just try this for yourself and you will see that this works. Okay, so with ps-aux, I can see all the processes which run on the system. If I grab this and I go pts, what I'm going to see here, I'm going to see the processes which are those terminal emulators themselves. And you see PTS0 and PTS1. And of course, this one here is this window. And then if I do TTY here, then this one is 0. And I can see this is the PID, the process ID of this window. And then just underneath I have the process ID of this window. So now 17,179. So now what I can do is I can go to /proc 17,179 and I can look inside the memory of that process, and then there is a folder there, FD, so I can go inside of that and now I see different files. So if I do echo hi to 1, then you see that over here I got the word hi has been displayed. So I could again do this in my main.c, nano main.c. So it's just demonstrating a different way of doing this, and that will have the same effect. Right, so now when I call that program again every time I output here. Now you might wonder, what is the point of this? Well, number one, I just think it's cool, but in terms of practical reasons, what you could do is you could imagine that you're working on a program in this terminal window, and then you output some debugging information, and you don't want this to interfere with what you're doing over here, and maybe with what you know right now. You have a nice layout in your program, and any output of debugging information would interfere with that, so you just output it to another window. Right? This is something you could do. Alright, so now I have this program hello, which allows me to draw this text anywhere in the window. I would like to put it in the center of the window. In order to do that, I need to know the size of the window. So I have here now in tc.h, I've included this header file ioctl, so input output control, which allows me to call this function here, ioctl, and this will give me the number of columns and rows, and ioctl is a syscall, so the kernel will tell me the number of rows and columns in the terminal. Yeah, basically that should do it. Maybe I just want to actually do a proper prototype here, so just in case I put more functions after this. Okay, so now I'm gonna go to main.c. So here I have this function, get calls and rows, and now what do I want to do? I want to move to the center, so the center would be the rows over 2. So I could do columns minus 12 over 2. Alright, and that should center the text. So let's see how that works. Right, that should be in the center now. And if I change the size of the window, then I have it again in the center. Alright, so now you have this Hello World program where you can put this text in the center of the window no matter the size of the window. What if I change the size now? Well, now it's no longer in the center. It will center itself again if I rerun the program, but you probably would like something which can recenter itself as you're changing the size. So here you need to imagine like a proper application with a main loop. How would you recenter the text, or how would you like redraw whatever you see in order to keep things always centered and always in proper proportions relative to the size of the window. So in order to do that, you need to catch a signal. So let me just look at the main file here. To catch a signal, I'm gonna need this header file, and this is a syscall. So, and then I'm gonna put it here at the very start, signal, and the name of the signal is SigWinch. So this is the signal that will tell you that the size of the window has changed. And then I need to put a callback there. So I'm gonna call this like hello window changed, something like that, right? Okay, so this is the name of the signal, and this is a callback. So this is the name of the function. We're gonna write this function in a second. This is a pointer to the function, and once that this event occurs, the signal is sent to the application, then this function is called back. So a function like that, when you give a pointer to a function, this is known as a callback. So let's write that function here, and I'm just gonna do this the lazy way and just copy the code, which obviously normally you wouldn't want to duplicate code like that, but this will do. Yeah, and also because I want the application to keep running, I'm just gonna put this. Okay, so let's see if this works. Right, and so now when I change the window size, there you are, until I press a key, and then right. Alright, so what is another thing I may want if I were to create a full interactive application in the terminal? Well, if I use nano and I go main.c, I see that the entire screen of the terminal does change. If I get out of this, I get back to a different screen, right? So I don't just see the screen of the terminal or the screen of the editor and the prompt suddenly appearing there. It's like there's a different buffer in the terminal that I'm going back to. And this is again achieved with escape sequences. So let me show you that. So if I go to tc.h again, I've added those two functions here. So tc enter alt screen and tc exit alt screen. So now if I call them from within my Hello World program, so here tc enter alt screen, there. Now we compile again. Okay, and now I press enter, and then we go back to the screen we were from. So now if I start the Hello World program, okay, you can see Hello World in the center, and now it is executing the get car. So if I type, you can see that what I type shows up on the screen, and then I'll press enter. And so I'm gonna show what we have here is this get character. Until I press enter, everything I type will actually show up on the screen, and that's probably not what you want. So what we can do here is we can turn off the echo. Now echo is simply whether or not you will see you will see what you type, right? So if I save this and then if I compile again and I do hello, and then now as I type, I am typing, but you're not seeing what I'm typing, right? And that is handy for when you type in basically keys for menu options. You don't actually have to see those letters appear on the screen. You just want to move through the menu. And so this is how you can do that with turning on or off the echo. So if I show you how that's actually achieved in tc.h, so why am I doing this? No, let me show it with this. So going down here, what we have is we have this function tc get attribute. It gives us the attributes of the terminal. Those attributes get loaded into this struct, and then we are turning off echo in those flags, and then we're using the same struct to set the attribute. And this is this part tcsa now just means we want the attributes to be changed with immediate effect, right? And I'm doing something very similar here to turn it on, right? So turning it on and turning it off. Okay, so that's basically what I wanted to show you. I hope you enjoyed that. I hope you learned something. You now basically have all of the essential components to make interesting interactive applications within the terminal. If there is demand for it, I might make a follow-up video where I make either a game or some kind of application where I use most, if not all, of the things I've just demonstrated. So just let me know in the comment section whether you would like to see me in a follow-up video make a full application, either a game or some other application. So until then, I hope you like and subscribe. I hope you enjoyed. And oh yes, by the way, the code will be available on the GitLab. You will see the link in the description. So until then, thank you for watching.